For problem 6.3.4, it asks us to finish the molecular equation and then write the total ionic and net ionic equations for each of the following reactions. So for part A, we have calcium hydroxide and acetic acid. And the first thing we have to do is figure out what the products of this reaction are going to be. So, this is going to be a double replacement reaction, so I'm going to swap anions that are paired with cations. So, first things first, we need to recognize the anion and the cation in the acetic acid, the polyatomic ion, the acetate ion. And so, we are going to swap our partners and have HOH, which you could also write as H2O, but I like to write it as HOH so I can see the double replacement occurring. And then I'm also going to have calcium acetate. And to balance the charge, I'm going to have 2 acetate ions for every 1 calcium. Now, if I go back and I look at the solubility rules in this section, I'm going to see that the calcium acetate is going to be soluble, and I'm going to have pure liquid water. So now I'm going to go and I'm going to write, first I'm going to balance the equation, and it turns out that I need 2 acetic acids and 2 waters for it to be balanced. So now I can write the total ionic equation by breaking everything that is aqueous into its constituent ions, making sure that I keep any sort of balancing or subscripts with me to keep the equation balanced. So anything I have as a coefficient is going to stay as a coefficient, but any subscript I have is also going to become a coefficient. So you'll see the 2 on OH2 became a coefficient of 2, so I have 2 OH minuses, and the 2 in front of the acetic acid also became a 2 on the H plus and the acetate ion. Now you could be writing aqueous with all of these. I find it slightly tedious, and I tend to only put state symbols on the things that aren't aqueous, but it would be proper to be writing aqueous on every single one. The waters are going to stay together because they're a pure liquid. They're not going to break up in solution like the aqueous ions are. And then I'm going to have Ca2 plus and 2 acetates. Again, both of those would be aqueous. And that 2 is coming from the subscript of 2. So that's going to be the total ionic. Now I'm going to write the net ionic, and the difference between the net ionic and the total ionic is anything that is a spectator ion gets canceled out. So anything that is an ion on both sides of the arrow doesn't get written. In this case, that's going to be calcium, and that's going to be acetate. And I see that I'm canceling out the same number on both sides of the arrow. That is important. And so the net ionic is going to be the 2 OH minuses, the 2 H plus, yielding 2 H2O. That's not balanced. Yes, it is. I got tricked because HOH, 2 H's, 2 OH's. That's why it's always important to count correctly. Even your professors can be fooled into thinking they haven't balanced an equation correctly. So part B is going to go the same way, except this time we are taking phosphoric acid and we are adding calcium chloride. And once again, this is going to be a double replacement reaction where we are going to create calcium phosphate which I have to balance the charges on, so it's going to be Ca3PO4 and HCl. And if I look again at my solubility rules that are in this section, I'm going to see that calcium phosphate is going to produce a solid and HCl is going to be aqueous. And then I can go ahead and balance the equation. I need 2 phosphoric acids, 3 calcium chlorides, and 6 hydrochloric acids. So now I'm going to go ahead and I'm going to write the total ionic equation, remembering to keep track of my subscripts and my coefficients. And in this case, I'm actually going to have to do some multiplying in some cases to have both kept track of. So I'm going to have 6 H pluses because 3 times 2 is 6. And then I'm going to have 2 PO4 minus. Again, all of these are aqueous. Plus 3 Ca2 plus 6 Cl minus. Again, 3 times 2 is 6, but only 3 times 1 is 3. And that is going to yield the calcium phosphate is going to stay put together because it is a solid in solution. So it doesn't break up into ions, it stays a solid. And then 6H plus and 6Cl minus. And again, I'm going to look for my spectator ions and cancel those out so I can write the net ionic. I'm going to cancel out the 6Cl minuses and the 6H pluses, and again, making sure that I cancel out the same amount on both sides. That ensures that my equation is correctly balanced. And so for the net ionic, I'm going to have 2 PO4 minus plus 3 Ca2 plus gives me Ca3PO4.